The activity series. So if we take a piece of magnesium metal and we put it in a solution of copper ions, a chemical reaction will occur. And we'll see that there's electron transfer between the magnesium and the copper, and magnesium will dissolve and the copper will deposit onto the magnesium strip. It just happens all by itself. If you do the reverse and put a strip of copper into a solution of magnesium ions, nothing will happen. So how do you tell which reaction is going to happen? Because this scenario would be copper plus magnesium ions going this way. Why does it go in the forward direction and not in the reverse direction? So there's an activity series. Some metals are more active than others, and there's a list of them. Metals at the top of the list have the greatest tendency to lose electrons. Losing electrons is oxidation. So they'll go from a metal element to an ion, which would be dissolved in water. And so they will react. Metals at the bottom are the least reactive. They have the least tendency to lose electrons. So here is a partial activity series. It does not list all the metals on the periodic table, only the ones we're most commonly encountered. So when lithium loses electrons, reduction is gain of electrons, oxidation is loss of electrons. So this is an oxidation reaction where the lithium is going from a lithium atom to a lithium ion and it loses an electron. So all of these reactions are written this way. Lithium is the most likely to do that. Gold is the least likely in this series. And then we have one nonmetal in here, which shouldn't surprise us because hydrogen works his way into everything, right? And he always has to be a little bit different. So hydrogen is in here also. When hydrogen is oxidized, the hydrogen molecule forms hydrogen ions. So what this list says is if we take, like that previous example was magnesium and copper. So here's magnesium, and copper's way down here. So magnesium is more reactive than copper. So if I put magnesium in contact with copper ions, a reaction will occur. If I put copper in contact with magnesium ions, no reaction will occur. So that doesn't always make all that much sense. Do we have should have an example. Well, I'll just keep going with that. So gold is way down here at the bottom. Gold is very low on the activity series. And because of that, it resists tarnishing and corrosion. You have a gold wedding ring. I never have to polish this thing. It always stays nice and shiny because gold doesn't react with much of anything. Silver, although it does tarnish, is much less reactive than many other metals. And so these metals are used for jewelry because they're very stable and they don't react. Some of these other things will react very easily with acids or salts in different solutions, and so they're not going to make very good jewelry. Here's iron. Iron is more reactive than these guys down here. Lithium and potassium and calcium are so reactive, and sodium. These guys are so reactive, they react with water. And so, you know, that would make really crappy jewelry because if you sweated or washed your hands, your ring would react. That wouldn't work out so well. So metals at the top are more active. So let's look at an equation and how to use this list. So here I've just cropped that list. All we really need to know is the order of these metals. And I don't expect you to memorize this. I don't have it memorized. If you need it on an exam, I'll give it to you, or I'll give you the pieces of it that you need. Okay? So this is how you use this list. Bless you. And this is one of the questions in worksheet 16 that you couldn't answer last night because we hadn't finished this. So determine whether each redox reaction is spontaneous. So that example with the copper and the, was it magnesium or zinc? I don't remember. Let's go look. Magnesium? Yeah, magnesium. So what this question is saying is, looking at an equation like this, a chemical reaction, is this going to happen spontaneously all by itself? The reverse reaction would be copper plus magnesium ion to form copper ion plus magnesium metal. How can we tell which one of these is going to happen spontaneously? You can make the reverse reaction happen by forcing it with electricity. It's called electrolysis or electrodeposition, and you can make that happen, but which one will happen spontaneously? So let's go back to our question here. So to answer this question, we're going to look for zinc and nickel on the activity series. So here's zinc and here's nickel. So zinc is higher on the list. Zinc metal is more active. Zinc metal will react with any of these metals as ions. A reaction will occur. So because nickel is below zinc on the list, a reaction will occur. Okay, that's kind of hard to remember. So let's put this in terms of people going to a party and hanging out, right? So this is a net ionic equation. Let's put the cations in there. Here we're just looking at the guys. We need a girl in here. So let's use chlorine. So zinc plus nickel chloride going to zinc chloride plus nickel. So this is a single displacement reaction. So the metals are the guys. So here's a guy, and he's going to go to the party all by himself. And nickel brought a girl. He brought chlorine. They go to this party, and chlorine ends up going home with zinc. Why would the girl go home with a different guy? Attraction is stronger. He's cooler, more macho. Something about him is better, right? So this guy came by himself. She came with nickel, but when she sees zinc, she's like, he's hotter. I like him better, and she leaves with him. So this is the list of hotness, okay? Lithium's the hottest guy. Isn't it ironic that you could be really hot and really cool, and that means the same thing? How is that? Anyway, so whoever's highest on this list is going to go home with the girl. So we look at this zinc, and here's nickel, and in this reaction, there's a girl somewhere, but we just don't know who she is. Zinc's going to go with her, and nickel's going to go home by himself. No charge means they're going home by themselves. So will this reaction occur? Will this happen? Yeah, because zinc is cooler than nickel. He's higher on the list. This is the order of preference that girls would like to go home with these guys. Some movie star list or something, I don't know. Let's look at this one. Zinc and calcium. So we got to find these on this list. So here's zinc, and here's calcium. So this is the ion. Imagine it. This is with the girl. I don't know why I'm picking on chlorine, but there's chlorine. And here's zinc coming in. So chlorine came with calcium. And at the party, there's zinc. But if she came with this guy who's third on the list, why would she leave with that guy who's lower down on the list? She wouldn't. She's like, I've already got the coolest guy here. I'm not going to settle for this other guy wearing the wrong clothes, or he's got a bad haircut, or his breath stinks. I don't know. Something's wrong with him. So she's going to stay with him. No, this reaction's not going to happen. This is what would happen if they swapped partners, but it's not going to happen because she has more sense than that. So this is not happening. So do you see how that works? The metal without a charge is the guy coming alone. The metal with the charge, the ion, that means that he's with somebody. To determine whether this reaction occurs, you find out which guy is higher on the list. Here, zinc is higher than nickel. So zinc's going to take the girl home. Zinc's going to end up with a charge. He gets a charge out of the girl. I don't know. This can go off in all sorts of inappropriate directions. Here, zinc came in alone. Calcium's got the girl. And we see that calcium's going to keep her because he's higher on the list. Okay? That's how I remember it. Yes? Why did I put the Cl2 in there? I just put that in there so that we'd have a girl to talk about. So this, when we're just looking at this, it's kind of hard to bring the whole boy-girl analogy thing in. If there is a nickel ion, there has to be an anion somewhere. It's just that this is a net ionic equation, and so it's not written. But there would be an ion there. Does that answer your question? It could be anything. So this is kind of the generic thing. This guy came with a girl. Does it matter which girl he came with? No. He has the girl. The question is who's leaving with her. And it's here it's zinc. This one's not going to happen. We can write the equation, we can balance the equation, we can do all kinds of calculations with the equation. But you put zinc and calcium ions together in a solution and nothing's going to happen. Nothing. Now the opposite reaction will occur. If you put calcium metal in a solution of zinc ions, a reaction will occur because calcium is higher on the list than zinc. And so calcium's going to take the girl from zinc. Yes?
So that top was spontaneous.
Yes.
So you have the solid mixed with the
Ion.
What if it's the ion first and then the solid?
Doesn't matter. The order doesn't matter.
So when they're doing that,
so if you have the ion first and then the zinc, that reaction is still going to occur. Because you're still comparing who's higher on the list. So here's zinc and here's nickel. The metal, as it's written, if this is higher than the ion, reaction occurs.
It's got to be the solid combining with
It's got to be it has to be the element and an ion. If you put two metals, zinc metal and nickel metal, the elements together, nothing's going to happen very much. It's the ion and the metal. Does that answer your question?
Yeah.
Because these chemical equations are a lot like math equations, except the arrow gives us a direction instead of just saying equals. But if we write zinc first or nickel first, it's adding. It doesn't matter which one comes first. And the same for the products. It doesn't matter which one comes first on that side of the reaction arrow.
Does their charge matter?
The charge matters only in the sense that one has a charge and one doesn't. So, like for example, well, neither of those is a good example. Let's make a new example. I forgot where to do that. Well, that'll work. So let's say we had iron 3+ and copper. Just picking two metals out of thin air. Got them out of thin air. Is a reaction going to occur between these? Well, we need to look at our list here. Find copper. Copper's down here, and here's iron.
It would if iron's solid and the copper's in a sleeve.
Right. It would happen if we had iron plus copper ions. Because this guy's charged because he has a girl. Maybe that's a good way to think of it. So he's stoked. He's got the girl, but here comes iron. And iron is higher on the list, and so he's going to take the girl, and he's going to end up with a charge. Now, iron can make different charged ions, and so could we tell exactly which charge he would take? No, we can't, but we can say that reaction is going to happen. Here, iron's charged, he's stoked because he's got the girl, and here's copper. Copper's lower on the list. He can't take the girl from iron. So this is not going to happen. This is no reaction. It could be iron 2+ reacting with copper. Here, iron's got the girl reacting with copper. Nope, iron's higher on the list. He keeps her. Again, no reaction. Which charge the ion has doesn't matter in terms of whether the reaction will occur or not. It's who's higher on the list.
But if it has a charge, then it's not going to react.
Well, if this one having a charge, we're comparing it to copper. So it has a charge. We think of that as having a charge. You got the girl. Copper, no charge, no girl. And so when we compare these, we can tell that whatever they started out with, iron's going home with the girl. He's going to have the charge. If he had it to start with, he's going to keep it. If he didn't have it, he's going to get it. Does that help?
Yeah, so it doesn't mean they'll react just because it's below. It doesn't mean they'll always react.
If the thing that has the charge is below the one that doesn't have the charge, it will react, but not the other way around. You're almost there. You had a question in the back?
No, you answered it.
Okay. So, in this situation and in this situation, iron has a date. Okay? He goes to the party. Copper didn't bring a girl, but because copper is not as cool, he's not as high on the list as iron, he can't take that girl from iron. Does that make sense? Here, iron came by himself. Copper has the girl. He's charged because he's like, I got the girl. She's going with me, right? They go to the party. Everything mixes and mingles. The girl recognizes that iron is more desirable, and so now iron has the charge because the girl's going with him, and copper's sad because he's all alone. I mean, you can make these analogies as ridiculous as you want. The crazier they get, the more likely you are to understand them. This is a very abstract concept. An activity series of metals and predicting which is going to react with which ion. This is like, wow, how does this relate to life? So I'm trying to pull it into something we understand. Maybe it's a little sexist, I don't know, but we got to deal with the positive, negative charges. This is my best thing I've got going here. Any other questions? So we can use that same activity series to predict whether a metal will dissolve in acid. Some metals dissolve in acid, others don't. Most of them do this by reducing hydrogen ions from the acid into hydrogen gas. We saw a reaction like this yesterday in lab, but with magnesium. Yeah, question?
From the list of the elements,
Uh-huh.
that's going to be on the test. Are we going to be given that list?
Yes. I'll give you the activity series. There's no point in memorizing that. I don't remember what it is. I could guess at some of the relationships, but I don't have it memorized, so I don't see any point in making you do that. Yesterday we put magnesium in acid, and it bubbled and made hydrogen gas. We collected it in a test tube, and it ignited, right? And it was kind of fun, and some people found it a little surprising and scary. That's okay. But nobody got hurt. It was fun. So the way we can tell if a metal will dissolve, if the metal is above hydrogen on the activity series, it will dissolve in acid. If it's below, it will not. The only exception that we need to be aware of is nitric acid. Nitric acid can dissolve some elements below it, It does so through a different half reaction, through a different type of reaction. So I won't ask you to predict anything with nitric acid, although it could be on the worksheet. I don't know. So let's look at this example. So does silver dissolve in hydrobromic acid? Okay, the identity of the acid here, all we need to know is it's not nitric. If it's not nitric, we don't care what other acid it is. So what we're looking at here is, will there be a reaction between silver and hydrogen ion? So in my analogy, does silver have a girl? Nope. Does hydrogen? Yeah, he's got a charge. So we're going to find these guys on the series. Silver's down here, and hydrogen's up here. So who's more desirable, hydrogen or silver? Hydrogen. So hydrogen's going to leave with the charge. Well, hydrogen already has the charge. He came with the girl. Silver, although he's got a really nice name, it's a cool name, but not as desirable as hydrogen. So this is not going to happen. Silver will not dissolve in hydrobromic acid. So it's the same idea, just that hydrogen isn't technically a metal. But this is kind of one of the reasons why he's over there on the periodic table with the metals, is because sometimes he acts like one. Any questions? Yes?
Did you do slide 14 to 23?
No, we didn't. We did not do the slides in, I think that was section 16.4. Yeah, we're skipping that. I've lectured on that in other classes, but in looking closely at the course outline, that subject of balancing by the half reaction method is not on the course outline, so we're going to skip it. Hooray! If you want to learn it, I'd be happy to talk to you about it outside of class. Is this the last slide? Yeah. But let's make up another example. Pick a metal. Lead. So, oops. So lead. Will lead dissolve in hydrochloric acid? Will this reaction occur? So this is H plus and Cl minus, right? So here hydrogen has the girl, and lead's coming in. He's going to try to take her away. We have to find him on this list. Here's lead, and here's hydrogen. So lead he's only one step above hydrogen, but he's still more attractive to that anion than the hydrogen, and so this will occur. So we're going to get lead something. Can we predict what exactly we're going to get? These are the two possible ions. No, we can't. And then you're going to get hydrogen gas being formed. I won't ask you to write an equation for that. But you might be given an equation already written out and asked, does that occur spontaneously? And you'd be able to say yes, because lead is higher on the list than hydrogen. And so lead is going to take the charge from the hydrogen. Okay? Any questions?